A basic tutorial on how to solder. The tools and equipment required to perform this task are listed on the right-hand side of the screen. Eye protection should always be worn when performing any part of this task. Here we can see a close-up view of our guide. Begin by cutting your tubing. Each piece of tubing should be cut to be about 5 to 6 inches in length. Place the pipe cutter onto your tubing and gently tighten. Once tightened, rotate the piping cutter. Once tightened, rotate the pipe cutter and continue to tighten during this process. Do not over-tighten the pipe cutter as it can crush the line. Do not allow the pipe cutter to completely cut through the line. Once the pipe cutter has made it through the majority of the line, snap the line off by hand. Continue this process on the remaining tubing with the exception of the capillary tube. Next, bend 4 sections of the 1/4 inch tubing into 90-degree elbows. This can be done by hand or by using pipe benders. If using a pipe bender, place the tubing in the appropriate slot and then close the handle until the desired angle is achieved. To sand the tubing, rip off a 6 to 8 inch section of sandpaper. Next, tear that piece of sandpaper in half lengthwise. Loop the sandpaper around the end of your tubing and thoroughly sand. The tubing should be evenly and thoroughly sanded on all sides. Be sure that the tubing is being wiped clean with a dry cloth anytime it has been sanded or handled before soldering. After the capillary tube has been sanded, cut the end with a capillary tube cutter. After it's been cut, the capillary tube should resemble a hypodermic needle. This ensures that refrigerant freely flows through the capillary tube and prevents restrictions. To sand the steel tubing, begin by using your torch to heat about 1 inch or more of the end until it's red hot. The steel tubing is powder coated and can be difficult to sand. By burning the coating off with the torch, the sanding process is made much easier. After the steel has been left to cool for several minutes, thoroughly sand it. Again, any tubing should be wiped clean with a dry cloth after sanding or handling. To swage your 1/4 inch lines, place it into a flaring block or flaring clamp about 1/2 inch. Thoroughly tighten your block and then place on a clamp. Drive your swage into the 1/4 inch tubing with your hammer. The swage should be gently driven into the tubing until it's fully seated. It may be necessary to remove the swage with pliers, however most times it comes out freely by hand. Here we can see that the tubing has not yet been bent. The swaging process or bending process can be done at any time after the tubing has been cut. Remove the tubing from the block and repeat this on one more piece of 1/4 inch tubing. Here we can see that the 3/16 inch steel tube will not quite fit inside the 1/4 inch tube. To allow them to fit, swage the 1/4 inch line with just the nipple of the swage tool. Here we can see that the two lines now fit easily together. Place the capillary tube no less than 1 inch into the 1/4 inch tubing and then use your pliers to crimp the 1/4 inch line. Repeat this process on the other end of the capillary tube. After the capillary tube has been crimped, the remaining pieces can all be fit together. After being fitted, place them into a vise and hold it upright. Here we're using OD products to solder, however Harris products are recommended when in the field as they are superior. Bend a small elbow at the end of the solder to prevent overusage and clogging lines. This also allows for easier access on the backside of the lines. Begin at the bottom of your model with the steel to copper connection. The male part of the tubing should always be heated first for 1 to 2 seconds. The torch should then be brought back directly over the joint. Observe for your copper to change color and then apply your flux. When using tinning flux, if the line is at the appropriate temperature, it should turn silver in color. After the flux is applied, reapply the heat to the joint. When your joint is up to temperature, move the heat behind the joint and apply your solder. This draws the solder deep inside the joint. Allow the joint to cool for 1 to 2 minutes and then wipe clean with a wet terry cloth. All joints must be cleaned after they've been soldered as the flux is a corrosive material. Here's a closer view of our steel to copper joint being soldered. Again, the male tubing for 1 to 2 seconds and then the heat directly on our joint. Observe for the color change and then apply your flux. Bring the joint back up to temperature and then move the heat source behind the joint and apply your solder. Only small amounts of solder are required to properly seal a joint. Here we can see the color change in the line after it is cooled and is ready to be cleaned with a wet cloth. Next, we will solder the top of our model. Whenever soldering around a Schrader valve, it should be removed as it can become damaged by the high heat. The cap itself is the Schrader valve removal tool. It threads left to loosen and right to tighten. Solder the 2 joints at the T-valve. The same process used on the steel to copper connection will be used on all connections. Before reinstalling the Schrader valve, be sure that the line has been cooled and can be handled by touch. Next, solder the 2 connections for the capillary tube. When drawing solder up, it's important to understand that you're fighting gravity and drippage is normal. The best practice is to ensure that the flame is placed behind the joint when applying the solder to draw it upwards. Solder the 2 joints on the right-hand side that you've flared to complete the soldering process. Here's a close-up view of the flame being placed behind the joint to promote the upflow of solder. After being cleaned, we can see that the solder did flow down, however also did flow up and completely sealed the joint. Here's our completed project and ready to be tested. Bend and manipulate your model to test the joints and ensure that they do not break. If done properly, the joints are stronger than the tubing itself. If a joint breaks, it has failed and the soldering process was no good. Lastly, pressurize your model and test it for leaks. This can be done by hooking it up to an air compressor or a tank of nitrogen. It is recommended that it is not pressurized more than 50 to 75 psi. After it is pressurized, it can be dunked into a tank of water to check for bubbles or sprayed with leak detection solution. If using leak detection solution, it's important to understand how the solution works. Bubbles are naturally created in the solution when it is sprayed from the bottle. Larger leaks will appear as larger bubbles, usually about the size of marbles to golf balls, while small leaks will typically create a white froth directly on top of the joint. If you desire, you can cut the capillary tube to release the pressure in the model. Air should be released from both sides, indicating that the capillary tube was not soldered closed.